Welcome back. This is the fourth video for Chapter 8, Writing Classes. This video is really the second one regarding how to actually write classes in processing. In the previous video, we designed the Dude class for our Mosh Pit example. In this video, we're going to briefly look at the design for the client program, that is the actual Mosh Pit program, and then talk about how to actually code classes in the processing IDE. So now we're turning our design attention to the actual application program, and this one will design in a similar manner to how we designed Solo Pong in Chapter 6. That is, we're going to design the application program using our top-down methodology. So our Mosh Pit is the application that we're designing. It'll have three methods, very similar to what we usually have: setup, draw, and stop to turn off the audio assets at the end. Our setup method we'll call a create dudes method, which will create our array of partygoers. And then the draw method we'll call a get level method, and that method will determine the level of the audio so we can adjust the concert goers' mosh pit speed appropriately. A quick UML diagram will show us the fields that we'll need in addition to the methods that we just talked about. We'll have three constants, one of which is the background color for the application, the number of dudes in the mosh pit, and a speed scale value. And what that is a scaling constant that we'll use to multiply the song's level so that the concert goers move in a appropriately festive fashion. The other really important field that we'll have is our dude array. So that will incorporate some of the concepts we learned in Chapter 7. And then we'll have our audio assets, a loader and a player. Now our create dudes algorithm is very similar to some of the algorithms that we saw in Chapter 7 that created arrays. The only difference is that this one is not going to return the value, since dudes is a class variable. But in any case, we create the array. Remember that just creates an array of references. The actual objects don't exist yet. So the next thing we have to do is a for loop that goes through and populates that array. And for each element, we call the dude default constructor to randomly place that mosh pit participant somewhere in the mosh pit. Now when we start looking at determining the level of the song, what we have to think about is what that would actually look like. Well, our song could be represented as a waveform, something like this, and it's periodically sampled so that we know what level it is. So what we'll do is we'll take a look at all these different sample values, average them together, multiply them by the speed scale, and that will give us a snapshot of the volume or the level intensity of that song. We'll do that every time we draw a frame. We'll get a chunk of the song, look at its level, and adjust the speed accordingly. And this is an algorithm that expresses that idea. We're going to get our data from the audio player. This will be from the mix channel, so it'll be actually looking at both channels, the left and the right stereo channels. And that data is actually an array of floats. So in the next piece, we're going to add up all the values in that array. Then we're going to divide that by the length of the array to produce an average. Take the absolute value so that we don't end up with a negative number. Multiply by our speed scale, which we had to find out via trial and error, basically. And that will give us a new speed value that we can use for the concert goers, sort of their maximum speed that they can move in a random fashion. Lastly, before we turn to the coding aspect of this example, let's look at our draw method algorithm. We're going to handle dude-on-dude collisions first, and so this nested for loop structure goes through all the possible pairs of dudes to determine if they collided with each other. And remember, the code for that is actually in the dude class, and so that's why this looks relatively simple. After that's done, we'll determine the level of the song at this point in time, and then go through all of our dudes, set their new maximum speed to that level, handle any collisions with the walls, update their position, and draw them on the interface. So that's a quick tour through the design of the application program. There are more details in the text, but now let's turn our attention to actually writing the code in the processing development environment. Okay, so we're going to start with the application itself, and then we'll look at how to create a new class. This follows the algorithms and the outline that we just created in this video, and then we'll look at the dude class shortly. So up at the top we have our constants, speed scale, number of people in the mosh pit, background color, our array of dudes, and our loader and our player. Setup method sizes the window, turns on smoothing, loads our audio, creates our array of partygoers, and starts the music. In the draw method, this follows the algorithm that we just looked at. We erase the background, handle collisions between pairs of dudes, and then update our speed value by determining the level of the song, iterate through the dudes array, set their max speed, see if they run into a wall, update their position, and draw them. Stop method simply closes our audio assets. Create dudes creates the array of dude objects, and then populates that array with randomly placed dudes by calling their default constructor. And lastly, our getLevel method again follows the algorithm that we looked at previously. We get the mix channels data as an array of floats, add up all their values, and then finally determine the average and take its absolute value and return the speed scale of that. Now let's look at how we're going to create a new class. So to create a new class in processing, what we're going to do is click on this little triangle here and call it a new tab. Then we have to give it a name. So we'll call it dude, which has to match the name of the class. And now here we go. I have two tabs, one of which is the Mosh Pit tab, one of which is the dude tab. This tab will be the one that contains all of my code. Okay, so it would look something like this. And then if we follow our style guide that we talked about in the previous video, what we would have next would be all of our variables and our fields, rather, for the class. So we're going to have our constants for the max speed, radius, and then our coordinates. So we'll make them look like that. I won't bother to type them all in, but the code is in the text and you can find them in there. What's next according to our style? Well, it would be our constructors. In this case we only have one, the default. So we pick a random X and Y location for this dude that's being created, set the maximum speed, change the direction and speed so they move randomly, and choose a random color. And what's after that? Well, after that is our other methods. So our other methods are things like changing our direction and speed, which is just a random call to assign new values to dx and dy. Our drawDude method, which basically just draws a circle filled with this dude's color. GetX and GetY, which are accessors, so we could at all times determine where this dude is from the outside if we wanted to. Our collision method for other dudes, so other is the person we may or may not be running into. We determine the distance between our center points, and if that distance is less than twice a radius, then we have collided, and so we will change our speed and the other dude's speed and directions. wall collisions. We didn't look at this algorithm, but you'll find that it looks a lot like the collision code for solo pong. It's a little bit easier actually because we don't actually have walls, we just have the edges of the screen. But in any case, if we collide, we invert the appropriate speed value, and then we bump the person out far enough from the wall so that they don't keep colliding with it. Our set max speed is a mutator method. It just takes the new max speed value and puts it into this object. And notice this syntax right here. Our parameter is named max speed, but our field is also named max speed. So in the code we need to differentiate the two. This dot max speed means this object's max speed value, whereas max speed without the dot this means the parameter. So I'm taking the parameter's value, placing it into the field. And last but not least, we have our update method. And the update method simply updates this dude's position based on the dx and the dy coordinates. Now let's go ahead and watch it work.
All right, this is Oblivion.
Yeah, it is.
So there we go. That's our Mosh Pit application with a quick introduction on how to design and implement classes in processing.